Hello dear students, welcome to my YouTube channel. In this video we will see Perkin condensation reaction. We will see reaction statement and its mechanism. So like the video and subscribe the channel for more updates. Perkin condensation. Perkin reaction involves the treatment of aromatic aldehyde with anhydride of an aliphatic acid and the sodium salt of that acid and forms alpha beta unsaturated acids. So let us see the reaction. So when benzaldehyde when it has been treated with acetic anhydride, presence of sodium salt of that acid, sodium salt of that acid means acetic acid, sodium acetate, it is the structure, and it has been heated at 180 degrees Celsius and it will give cinnamic acid as the product. We started with benzaldehyde, after that acetic anhydride, and we got cinnamic acid. Aromatic aldehyde, that is benzaldehyde, and anhydride of aliphatic acids. So acetic anhydride, it is an aliphatic anhydride, and the sodium salt of that acid. So acetic acid, so that is sodium acetate we are utilizing, and it is been heated at 180 degrees Celsius and we get a cinnamic acid as the product. So these two molecules, benzaldehyde and acetic anhydride, it combines and it forms a cinnamic acid, and also it gives one more product, that is acetic acid. So we get this one more byproduct, that is acetic acid. Now let us see the mechanism of Perkin condensation. In mechanism, first step is formation of anion of acetic anhydride. So let us see by the structures. As we are using sodium salt of an acetic acid, that is sodium acetate, so here we will directly utilize sodium acetate and its anion. This sodium, it is departing and it forms an anion behind, and we will draw the structure here of an acetic anhydride. So I will bifurcate this hydrogen for convenience, and E double bond or oxygen, again COCH3. So it is the structure of acetic anhydride. Here the proton, it has been abstracted by this oxygen. This oxygen, it is having 3 lone pair of electron. One, it comes from an bond cleavage between sodium and oxygen, and so one of the electron pair, it will attack hydrogen. This hydrogen, it will leave its electron pair with a carbon, and this, it will form an anion of acetic anhydride. So further we will get anion And one more product that we get, it is an acetic acid, as the abstraction of an hydrogen it takes place. Now there are two lone pair of electron on this oxygens, both the oxygens, and one it has been utilized for formation of an bond with a hydrogen. Now in further step, there is addition of anion to benzaldehyde. So further I will directly write from here that there is further addition of an benzaldehyde to this anion. Here it will give alkoxide ion. So the electron pair which is available on carbon, so it will attack the carbon of an benzaldehyde, that is electron deficient carbon, and further there will be breaking of this oxygen and carbon pi bond, and this oxygen it is having two lone pair of electrons, so it will attack on the carbonyl carbon, and further it will form an alkoxide ion. This oxygen it is having 3 lone pair of electrons, and it is having a negative charge, as the bond between carbon and oxygen it has been broken now and the electrons are been shifted further. So there are 3 lone pair of electrons that are available, and it has formed an alkoxide ion. This alkoxide ion, in the next step it will be protonated. So further there will be addition of an hydrogen, so we will see further. In third step there will be protonation of an alkoxide ion. The alkoxide ion which has been formed, in the second step I will write the structure of it. Here the oxygen it is having a negative charge. There are 3 lone pair of electrons on oxygen. Remaining all oxygen they are having 2 lone pair of electrons as it is. So further it has been protonated. By using acid we can protonate it, and it will form a stable structure. So here one of the lone pair of electron it has been utilized for formation of bond with an hydrogen, and the remaining structure it will be similar. As of an earlier. Now further, there will be removal of water molecule. So when the water molecule it has been removed, so I will write in little bit bifurcated manner. The hydrogen from this carbon, it will donate the lone pair of electron towards the carbon-carbon, and it will form a double bond between carbon and carbon, and here the carbon oxygen bond it will break and it will carry away the lone pair of electron with itself. Now it will become 3 lone pair of electron, and totally the water molecule it will be loose. And once the water molecule it has been removed, so here the water molecule it will be removed. So there will be combination of this OH minus and H plus. Write directly H plus and OH minus. So whatever the bond lone pair of electron it has been coming from a carbon, it has been utilized for the bond formation with an hydrogen. So one of the lone pair of electron it will attack the hydrogen and it will form a bond and it will give a water molecule. So this happens after heating, right? As we have seen, the temperature it has been required, and we get the molecule further. Now this molecule it will be hydrolyzed in the further step. So let us see the further step. When we add the water to this molecule for hydrolysis purpose, we get two products. One is cinnamic acid and one is acetic acid. Let us see the products that we get after an hydrolysis. There will be cleavage from here. So it will be cleaved from this position, and OH from an water it will get attached to the carbonyl carbon. So when this H and OH and H, see here the breaking it will be in a such way that this oxygen, lone pair of oxygen, it will carry the electron with itself and it will attack the electron deficient carbon where it will get attached to the carbon, and now there will be breaking of this bond. The carbon oxygen bond it will break, and the lone pair of electron from an oxygen, as it will break, so it will break in a such manner that lone pair of electron it will be transferred on an oxygen, and one of the lone pair of electron it will be utilized for the bond formation with an hydrogen. So we get an cinnamic acid plus we get acetic acid as the byproduct. The name of this compound, that is cinnamic acid, and here it is acetic acid. Thank you for watching the video. If you are having any doubts, comment me in the comment box section. I will surely answer it.